Welcome to Multistack for the witness test of chiller job number 202Q041. Multistack is located in Sparta, Wisconsin and is proud to be American made. This view shows the entire array for your chiller. On the right we have the pump array, and in the background on the left the main mechanical array, and in the background in the middle we have the 3 mechanical module array, which sits around the corner of your building. The piping shown on the left here is the future free cool section. As we pan right, we see the pump and auxiliary array. Now we'll take a tour of that. Water comes in the return connection, through the strainer, into the tank, goes out of the back of the tank and through the air separator, which we can see in the background in the red, down into the pump suction, vertical pump discharge, up through the check valves, and over into the discharge, which feeds through the future free cool section. You can also see the orange Belimo actuator at the top, which is the free cool bypass valve. The section that angles up that we just looked through is the portion where we adjust from where the free cool connection would be at the lower height to the mechanical entering height at a little bit higher elevation. Water comes back through the mechanical modules and exits the array here to go up into the building. Let's take that tour one more time. Through the strainer, down through the tank, around and through the air separator, down and into the pump suction, through the isolation valves, then vertically up through the pump discharge, and down and over into the portion that goes through the future free cool area, up into the mechanical modules, back through the lower header of the mechanical modules, and ultimately out to supply chilled water to the building. The side of the array that we've been looking at, and that is shown here, is the building side, the side that the chilled water supply and return piping connects to. Now we'll move around to the back side where the VFDs are located, working our way toward where the stairwell is. There are 2 VFD cabinets with controls for local operation. Here's the serial number for the first pump. The pump cabinets also have a timer which automatically rotates the lead and lag pump. This can also be configured via the BACnet IP connection to each VFD through the building automation system. There are some close-up views now showing the variable frequency drive, the local start-stop switch which is found in each cabinet. Panning down to the right, we see the control power transformer and circuit breakers for the controls, and we see the power phase monitor, the blue and white device, and now a close-up of the serial number for the second pump cabinet. Moving around now to the side away from the building, we can see the air separator, the green expansion tank, bladder type expansion tank, and the green and white glycol mini feeder. As we pan right to see a view of the multi-stack test stand, the mechanical arrays come into view. Both the 4-module array, which is connected to the pump array, and then the 3-module array, which will be physically located around the corner. The fan coils at the top and the blue and red piping are part of the hydronic system that the factory uses to load chillers for our testing. In the center we see a heat stack. This is a heat recovery chiller and would be an alternative in this type of design in place of the free cooling module. This unit would provide chilled water as well as hot water hydronic heat for heating the building. Now let's get back to the tour of your chiller. Water comes from the background around and up into the air separator and then works its way right underneath the glycol mini feeder and the bladder type expansion tank before turning down to go into the pump suction. Now we move through the isolation valves into the pump suction, up through the pump discharge, check valves, isolation valves, and into the common header. From the top view we can see the Belimo actuator on the free cool bypass valve. This is installed for the future installation of free cooling modules in the currently open array, downstream of the pumps. This is the view of a standard free cooling module. A tour of this free cooling module will help you understand the piping configuration in the future free cool section between the pumps and the first mechanical array. There are 3 headers in a free cooling module. The one that is offset to the right is the entering water header. Water goes from that header up into the coils where the cooling occurs, and then down into the top of the 3 headers to enter the mechanical modules. The bottommost header, directly underneath the header that goes into the mechanical modules, brings leaving chilled water back from the mechanicals through the free cooling and ultimately out into the leaving connection from the entire array. That tour may give you a better understanding of why we have a 45-degree piping piece in your future free cool section. The water leaves the pumps at the height that it will enter the free cooling modules, but until those free cooling modules are installed, we need to 45-degree up and over into the entering connection point for the first mechanical module. The other important part of this tour is the piping and Belimo actuator to Mike's left. That system of piping and valves is the free cool bypass. Because we only have 2 free cooling modules and 7 mechanical modules, we need to bypass a certain amount of water during free cooling operation. The bypass valve and free cooling controller will accomplish this. Until the free cooling modules are installed, this will be deactivated and all of the water will pass into the mechanical modules. Now we'll turn the microphone over to Mike Orlikowski, Key Accounts Manager at Multistack, for a tour of the free cooling module piping.
Alright, so here we have our free cool module. This will be added on later. We have an entering free cool header. So we'll notice 3 headers here. That's because the free cool is in series with mechanicals, so this is our entering free cool header. Takeoffs will be used to get water to the, or glycol to the coil, and we'll dump into this top header. So that is why we see the jog over on the pump skid, which is for getting to the top header. That is where the water will meet up and continue on into the mechanicals. They will do their work, and then they're leaving on the mechanicals is here, which is the bottom header on that pump skid, which ends up being the leaving going back to the building.
Now let's take a tour of the mechanical modules. You can see the entering and leaving chilled water connection. And now moving around to the building side of the array, we'll see the master mechanical module. We'll pan right to left, but we'll come back with a little bit more time to review this component by component. You'll notice this control panel has 2 Corel controllers at the top. And as we pan to the left, this slave module only has 1. We'll explain that difference in just a minute. Now as we work our way right to left, we see incoming power go into 5 sets of circuit breakers. 1 for control power, 1 each for condenser fans, and 1 each for compressors. The gray compressor contactors, the Yaskawa Vfds for the condenser fans, a control power transformer, the manual off-auto switch, and again the Corel Pico controllers. My finger is pointing to the open spot on the slave module. It's a slave module because it only has 1 Pico controller. The mechanical master module has 2 of those controllers, 1 for the module itself and 1 to govern the operation of all 7 mechanical modules. Now we'll scan right to left underneath the control panel, seeing the 2 compressors, the evaporator, and the receiver. Moving around to the end of the module, we'll see the single point power junction box for the pump and auxiliary array and the first 4 mechanical modules. This yellow piping that's factory piping for the test stand shows the connection to the 3 mechanical module array, which is 90 degrees around the corner of the building. Panning up, we see the second single point power connection. This is the power connection for those 3 mechanical modules. You'll note the 224 amp door interlock disconnect switch and circuit breaker, and then 4 mechanical module breakers. There is a redundant module for future expansion factored into this panel. Panning right from the 3 module array to the main array, this is the single point power connection for both pumps, 4 mechanical modules, and the future 2 free cooling modules. This panel also includes a transformer for a convenience outlet. The power distribution block distributes power from the door interlock disconnect switch marked with the 400 amp service, and we see the nameplate data in the background. And now a close-up of the convenience outlet. As we look into the 3 mechanical module array, we'll note that the water headers are only present on one side of the unit. This is the building side of the unit. The upper header is entering chilled water and the lower header is leaving chilled water. This gives us counterflow in the evaporator, with refrigerant moving up as it evaporates and chilled water flowing from the top down. We see the 2 compressors and the tandem refrigeration set for the single refrigerant circuit in our module. Moving to the right, we see the evaporator, the variable flow valve, and the receiver. In this still shot, you can see the Belimo actuators of the variable flow valves in both of the modules on the building side of the array. The final part of our tour is of the end-of-loop bypass valves that will be on the 2nd and 3rd floors. Each of the valves has its own cabinet with a Pico Corel controller, taking a differential pressure input for the loop pressure and giving an output to control the valve. You see the inside of the differential pressure transducer, and the upper left-hand corner has a setting for A, B, C, and D ranges. The ranges are printed on the label at the top. This is an MS1 type device, giving you an idea of the ranges available. The differential pressure in the loop will need to be determined and estimated before committing. In addition, this valve assembly ships with the differential pressure transducer, allowing pressure equalization and use of the zeroing feature to calibrate the differential pressure transducer. Again, this 3-piece assembly, 1 for each floor, the end-of-loop bypass, the control cabinet, and the differential pressure transducer.